problem with a quadratic function dealing with a waterfall, and we want to find out the x-intercepts of the graph and what that means with the word problem. So here's our example. Angel Falls in Venezuela is the tallest waterfall in the world. Waterfalls erupted for 2,421 feet before entering the river below. The height h above of the river is in the feet going over the waterfall, modeled by this function, where t is the time in seconds after the initial fall. This is an example from page 346 in an Algebra 2 textbook, number 39a. So what we give you is the quadratic function. It's in standard form. This is your a, your b is 0, and then this is your c. This is your y-intercept of your graph. Imagine this waterfall going up and then coming back down to touch the ground. This is your y-intercept of over 0 up 2,421 feet. And then it goes over some maximum height, and then it comes back down and touches the ground. What we want to do is find out the time it takes for the waterfall to reach the river. So we're looking for that x-intercept. We don't really care about, imagine this quadratic function coming over here. This doesn't really exist, this x-intercept, because that would be negative feet. We're caring about this x-intercept right here. And what is it? So if you remember from our class, to find an x-intercept, we're looking for the 0 of the function. So I have the steps here. Set the function equal to 0, and then solve for t by factoring, undoing, or completing the square. You can use any of those three methods. So 0 equals negative 16t squared plus 2,421. I think the easiest way is to solve by undoing. So I'm going to undo and add 16t squared to both sides. So these cancel out, and we're left with 16t squared equals, and then on the right, 2,421. Then we continue undoing, so we're going to divide both sides by 16. The 16s will cancel out on the left. Then 2,421 divided by 16 is 151.3125. The next thing we want to do is undo the squared, so we're going to square root both sides, plus or minus the square root of 151.3125. Throw that into your calculator. And t equals plus or minus 12.30. Just round it to the nearest hundredths place. If we go back up to our graph, we have two x-intercepts, negative 12.3, comma 0, and positive 12.3, comma 0. This represents approximately 12.3 seconds for the water to continue this path and then touch the ground. So our answer to our problem is it takes approximately 12.3 seconds for the water to touch the ground from the waterfall.